Now, imagine this is a stem cell.
Stem cells are unique because they have the ability to generate new cells of almost any kind. They all start off as unspecialized cells, but
given the right chemical and genetic signals, the stem cells can divide to form slightly more specialized cells of different size, shape, and function. And after a few more cycles of division, these can give rise to highly specialized cells, like heart muscle cells, for example, that help your heart pump the blood around your body. Given a different set of signals, this same unspecialized stem cell can go down an alternative pathway and give rise to a different type of specialized cell, like a neuron that transmits electrical signals in the brain.
compared with stem cells from embryos, adult stem cells give rise to a smaller number of cell types, usually those of the organ or tissue in which they're found.
Now, researchers have found adult stem cells in more tissues than previously thought: bone marrow, skin, brain, liver, eyes, and this has led to research into using the patient's own adult stem cells to repair damaged organs.
Just bring your arms back your head.
And that's exactly the focus of the trial Michael Taylor is taking part in. Led by Professor Anthony Mather at the London Chest Hospital, the trial is vitally important because heart disease is still on the rise.
Cardiovascular disease is the #1 killer in the UK, with nearly 3 million people suffering with heart conditions in the UK, and about 800,000 people suffering with this condition of heart failure. He's got a condition which makes the heart very weak and baggy, and it doesn't work very well as a pump. And what we're trying to do is see whether his own stem cells can actually repair that heart and make it pump effectively again.
So if you're looking to repair heart tissue, do you need to use heart stem cells?
Ideally, yes. The problem is that there are very few of those cells in the heart, and we've only recently discovered that they're there. And the few heart stem cells that are present clearly aren't capable of repairing it. And that's really where we step in with our trials. By using bone marrow as a source of stem cells, we try and enhance the stem cells in the heart and their ability to repair the damage that's been caused.
This trial tackles heart disease on 2 fronts. Michael's bone marrow has already been stimulated to release enormous numbers of stem cells into his blood. And now, more are to be harvested directly from the bone marrow in his hip.
You okay?
Yeah, fine, thank you. Yeah, it wasn't that bad at all.
Good.
As this is still a trial, only some patients will have these stem cells re-injected. Although Michael will get an injection directly into his heart, neither he nor Professor Mather know if it will contain his stem cells or a placebo.
We're about to put either stem cells or placebo into his coronary arteries. We won't know which until the end of the study, when we've treated all of our patients.
This uncertainty helps the researchers to rule out the placebo effect from any positive results they achieve. Professor Mather feeds a tube through Michael's blood vessels right to the site of the disease in his heart. Incredibly, Michael remains fully awake throughout the entire procedure.
All right there, sir?
Yes, fine, thank you.
Good. Can't feel anything?
No, I can't feel anything.
So that's the first artery done. Now the second one, and then one more, and then we're all finished.